Hello everyone and welcome to a new video. What I have for you today is a meditation on a topic that has been brought to my attention a few years ago. Are feature branches evil? This is something that Thierry Despaux has worked on, and I think he makes a lot of good points, but I also have thoughts on this topic. So what I'd like to do is to first describe his argument and use a technique called Stillmaning, where we use the strongest version of the argument that feature branches are evil, and then go into a few things that I think are interesting to discuss. A few thoughts that I have on the topic. So before we start, let's look at the argument. What is the argument of Thierry regarding feature branches? Why does he think that feature branches are evil? And I have here his slides, which I downloaded from his website, and I'm going to go directly to the benefits of a feature branch, of trunk-based development. So basically what Thierry argues, and not only Thierry, there are multiple people doing that, is that you have two options fundamentally. You have the option when you deal with branches, you have the option of having a single branch, and everybody commits changes to that single branch. And this is a continuous integration practice. It allows us to keep everything integrated all the time. There are no parallel changes. There are no things that you do separately from the others. You just commit all your new changes to the main line. And this is, of course, this requires a few other things that you do. It requires you to follow certain practices. So you might need to hide the features that you develop on for a while, because this main branch will be deployed to production. And because of that, you might need to hide things that are not yet finished, which is okay, it's good enough, fair enough. You might need to think about feature toggles. You might need to think about modular architecture and allowing things to be on and off, depending on who is using them or on what time you are using them. So you can definitely use these types of things, and this is trunk-based development. The alternative to this is what many people are using, which is we have the main branch, we have feature branches that are parallel to the main branch, and on each of the feature branches we develop one feature. And perhaps it's a team developing a feature, perhaps it's a number of people, a pair or one person, doesn't really matter. And then you merge these feature branches at some point when the feature is done. And of course, this can be difficult. It's a practice that can lead to very costly merges, and not only costly, but also very annoying merges with a lot of conflicts. Because what you have is a bunch of feature branches that are changing in parallel, and maybe you end up, even if you end up with a single branch, you might have some conflicts if you did some fixes directly on the main branch. But there's also the case that you could need to merge multiple feature branches in the main line at one point in time, and then those feature branches have not been integrated with one another, and so it would end up in conflicts, right? But it's still a practice that's been used by many people. And I invite you to look at and to watch Thierry's talks and to read his article on this, because he's done a great job of bringing together the arguments for why feature branching is evil and what problems you might have with it. So if we are talking about trunk-based development, let's talk about the strongest argument for trunk-based development. And I'm going to quote from his slides. What he's saying is you'll have more frequent commits to mainline, which means more frequent builds. If you have more frequent builds, you'll find compilation errors faster. Also, more frequent builds means that you can run tests faster and you can find problems faster, right? It also means more frequent deployments. If you have more frequent deployments, it means reduced time to market, which is great, because if you have more frequent deployments, which are enabled by more frequent builds, which are enabled by more frequent commits, then you can end up with reduced time to market. It also allows you to do more experiments. So how you would build your product in this case, even if you have a bunch of teams, they all commit to the mainline, but the features are hidden until you say, okay, so now we are ready to deploy this. And it doesn't mean that you are deploying it to your full user base. You can deploy incrementally to your user base, because even if you have a good suite of tests, perhaps you still need to learn how the user base will interact with those features and how that influences operational parameters such as performance, response time, reliability, and all these kinds of things. So it's often the case, particularly for large products, that you will need to deploy little by little to or incrementally to parts of your user base. It allows you to do more experiments. It allows you to uncover more unmet needs. Yeah, because you keep seeing, and your business people, your product people can see the product. Even if the features are hidden, they can actually go there and start playing with those and see what things are not fulfilled, and even perhaps do usability tests, perhaps do other types of tests, and checks with friendly users that allow us to uncover more problems that they might have. And the second argument that continues this is that you'll have more frequent builds, which uncovers more problem earlier, fixes problems immediately, which means that you build quality in, which is a good thing because then you have better stability, better quality. And this is really a strong argument for trunk-based development. So why would we do trunk-based development? Why wouldn't we do trunk-based development? I'm a big fan of the approach that you should do whatever works for you, whatever enables you to do your best work in the current context that you are in. So it's very important to understand what this means. And I think Thierry has some very good points in the article that describes trunk-based development, that, and in his talks, that it's not only about trunk-based development, actually. And I've had a conversation with him on the internet, on Twitter. This is a part of it. As you can see, well, you cannot see the date, but it's been a few years ago. And my point with trunk-based development is not necessarily that it's not a good practice. You can definitely use trunk-based development. You can have great results with trunk-based development, absolutely. And if you decide to do so, perfectly do so. Here's the challenge that I see. We often go and work with teams that are not at a good level of maturity in terms of what I call incremental thinking. So incremental thinking means the ability to get a large problem and split it into smaller problems, and then solve each problem one by one until you end up with something that solves maybe the full problem, maybe 80% of the problem, maybe just a little bit of the problem. Incremental thinking is a way of thinking, and it's a, let's say, mental practice that applies on all levels of agile software development. We have, let's give you some examples. So we have an idea for a product. And our idea for a product is that it has to be a big product that solves 10,000 problems at once. The first thing that we should do in agile software development is figure out, okay, what is the thing that we could do that gets us the maximum value? And in order to do so, we can apply a few techniques. We can use impact mapping, we can use user story mapping. And we map out what we want to do, like all the ideas that we have, or we start from a goal and map out how we could achieve that goal in case of impact mapping. And then we figure out, okay, so what's the first thing that we could do that gets us high value? Think of it in terms of 80-20. Think of it like, okay, so what's a small feature that we could implement very quickly and that could get us the first users? And then which would be the next feature that would get us even more users, or which would reduce our costs? And this is just the first thing that you do. Once you do that, you go to user stories. And what are user stories? User stories are in fact pieces, incremental pieces of functionality. Or you could actually, and something that I like to do is frame them as problems. How do we do certain things? How does a user log in? How does a user create an account? You know, not the best examples, but these are perhaps the examples that everybody is familiar with. And once we do that, we have the user story that says, okay, as a subscriber to your newsletter, I want to have interesting content to read so that I can tell other people about it and feel good about it, okay? We look at these user stories and we try to split them into even smaller things, into the smallest thing that we can fit within a time box. So once again, we are thinking incrementally. Thinking incrementally, take a big problem, split it into smaller problems, solve each problem. What do we do with the user story then? Well, we think about acceptance criteria. What are acceptance criteria? Things, checks that this user story needs to pass through in order for us to know that the user story is working correctly and that the problem, or at least part of the problem, the one that we are targeting now, is solved. What do we do next? We write one automatic test for the acceptance test, and this test is failing, and we only use one, right? This acceptance test is failing, and now what we are doing is figure out what's the smallest check that we can make, and we write a unit test, we implement the code, make the test pass, and then we refactor. And this is test-driven development and acceptance test-driven development. These two cycles of test-driven development is the large cycle and the short cycle. But it's not only that, it goes even further. We go now into the code, and let's say we have something that works now. Okay, because the tests pass, we can prove that it works. Maybe even the acceptance test passes. We know that things are working correctly. What is next? Well, we look at how we can refactor. How do we refactor? We refactor incrementally. What does this mean? Well, we want, after each small change in the code still has to pass all the tests. Again, incremental thinking. So the problem with this is that you see how a simple practice, but quite difficult to master, influences everything. Everything from the moment we start a product to the moment we actually deploy. And I haven't even gotten to deployment, because even your continuous integration, continuous deployment stuff will be incremental. The first problem that you try to solve is how we build this thing, make sure it works, get it to production. But then we keep getting even more and more sophisticated things there. Perhaps we want to add additional checks for security. Perhaps we need to add additional checks for automated code reviews or for quality attributes. We want to run architectural tests, or we want to run tests related to performance and scalability and things like that. And you can slowly and incrementally improve your pipelines of continuous deployment as well. So you see how this is a practice that influences absolutely everything. And the challenge with incremental thinking is that it's really a way of thinking. It's a way of looking at things. When you see a problem, you immediately start figuring out, okay, so what are the smallest things that we can do to get closer to solving that problem, even if we don't solve the full problem. So let me go back to trunk-based development, and let me tell you one way in which you could do trunk-based development without actually doing incremental thinking. Turns out that if you're using Git, what you have locally is a branch. And by definition, it's a long-living branch. It's your local long-living branch. It's something that keeps growing. Now, you can push changes from this branch to the main line, but it depends how often you do that. Because if you are thinking incrementally, you will be able to push commits perhaps every 15 minutes, every 30 minutes. Let's say every hour, okay? Let's not go crazy. Let's say every hour. Although if you are doing test-driven development, if you are doing incremental refactorings, you should be able to commit every 15 minutes, most of the time. There are situations where you have a more complicated problem and you cannot do that. And you should also be able to push every 15 minutes because your local tests are passing. Your unit tests, your acceptance tests, they should be passing. You should be able to push to production. Cool, right? How many of you imagine what that means and how you do that? And this is the trouble that I have. People, so I all agree with the benefits of trunk-based development. Now here is the part of the argument that I find myself not agreeing with. And this is, it's not an argument that's stated, I think, very clearly, but it's something that I find stated behind the scenes, behind the words, which is the following. Given a team, if we start doing trunk-based development, then that team will learn how to do incremental thinking. And I think that this argument is not great. This is where I have a problem. I think that trunk-based development can be one of the triggers for learning incremental thinking, but it can also lead to situations where people just use their local branches as long-living branches, and they just don't commit often enough. They don't commit daily, perhaps they keep the changes on their computer for weeks, right? And of course you can work around that. But I'm also going to offer an alternative, and the alternative will be, what if we actually work with developers to learn incremental thinking? And they can decide later on whether we can show them, trunk-based or feature-based branches or whatever you want, but it's your decision how to do that. Because there's also the other part of it, which is I've used feature branches very successfully. My feature branches never lived more than a week. And we always delete the feature branches once they are merged into the mainline. Every day we merge from the mainline into the feature branch and we run all the tests there. And of course, if you have too many features in parallel, here you might get some conflicts. But the way this happens usually is that you could separate the areas where you work on, and it works fairly well. I mean, it's not perfect, but nothing is perfect. Trunk-based development is not perfect. Because one alternative, so let's look again at trunk-based development. It has many benefits. One thing that I don't quite like about it is that you need to do things like feature toggles or hide features in your application. And hiding features in your application is, let's see, I know that he's talking about hide unfinished new functionality. He also talks about the lean principle of reducing inventory. Well, I would argue that unfinished new functionality is still a form of inventory, right? If you have unfinished new functionality, let's imagine the following situation. You start working on a feature. You use trunk-based development. You push changes to the trunk. The feature is hidden. At some point you get an emergency and you need to switch to another feature. You start developing another feature, and now suddenly you have an unfinished feature in your code that sits there. This is inventory. Not only it's inventory, it also leads to potential security problems, because the security, the area of defense for security, the area of attack increases with the number of features that you create. And perhaps this is not a big deal, but what this means is that you need to be very careful that your hidden functionality is not accessible by potential attackers. And if it is accessible, even if it's not accessible, that you have the proper defenses, the proper checks, the proper security measures is taken care of, right? So it's not as simple as you write any type of code that you want, you push it to the main line, it goes into production and you don't care about it. You need to add some additional things. And of course, there are a few techniques. You can use branch by abstraction. You can use feature toggles. Absolutely. What feature toggles are basically a bunch of if statements in your code, which are very ugly. So here's the problem. Just to look at this. And to conclude this meditation on feature branches versus trunk-based development. So trunk-based development can lead to a bunch of great things. Absolutely agree. Will it always lead to those? Not necessarily. It depends on the maturity of your team. Feature branches. Are feature branches evil? No. I can use feature branches with the proper type of discipline. I can use feature branches in a very effective way. And they can enable things like experimentation and the ability to create. One thing that we would be doing sometimes is to create versions of products that we could show to different types of customers. So having these features somehow separated also allows us to kind of combine them into one build that we can check, and we can experiment with different types of solutions, different features for different customers, and so on. It also feels better in terms of architecture and in terms of security if, of course, you are taking the proper measures, if you are using the proper discipline. And the proper discipline is use short feature branches, make sure your architecture is modular, make sure you do incremental thinking, Make sure you have all the tests in place. Keep integrating the main branch. Delete the feature branch immediately after you've integrated it into the main branch. These are things that is just, proper discipline. Now, is this complicated? Yes, it requires some discipline. Is trunk-based development complicated? Yes, it requires some discipline. Do they both bring benefits? Yeah, absolutely. So that's why what I'm saying is I am very wary of situations when we say something is evil, never use that. We need to look at those in balance and see the pro and cons for both cases. And what I'd like you to understand, and everybody in the industry to understand, is that we really need to master incremental thinking. There's no way around it. We need incremental thinking on product level, on business level, on architectural level, on backlogs or building the products even if you don't use a backlog. What is the smallest problem that you can solve right now? On how we write the code, on how we deploy the code, on how we manage risks around operations once we've deployed the code, and so on. So incremental thinking is the thing that you should be looking at. To me, this is the core, the solution to the underlying problem of all these things, and not only to feature branches versus trunk-based development, but also to many other things, risks in business, risks in product, risks in architecture. A lot of these things go away if you master incremental thinking. So if you're interested in learning about incremental thinking, I'm actually considering working on workshops on this, learning programs that would allow you to master this. But no, it's not a simple thing. It's something that you need to practice. But we can practice on various types of problems and see how it applies to the general situations. All right, so what are your thoughts about it? Do you think that trunk-based development is the solution to avoiding evils? Are you using trunk-based development and have you found it useful? What were your challenges? If you are not using trunk-based development and if you are using something like feature branches, what are your challenges and how could you use incremental development? Let us know in the comments. Thank you so much for watching, and until next time, remember to think, design, and work smart.